So there it is. So value and mixture, which means money. Money is usually the thing of value. Value and mixture, money and mixture. Word problems. So here we go. So busload of campers stopped at a dairy stand for ice cream. They ordered 95 cones. It's a lot of cones. Some soft serve at $2 each, and the rest hard pack at 50 cents each. If the total bill was $116.50, how many of each type of cone were ordered? All right, it's a money word problem. Now, the crucial issue with money, when you're talking about numbers and word problems, is knowing whether when you're talking about the money, you're talking about monetary amount or objects. For example, what if I say, hey, I'm going to tell you about $10 bills. I got $10 bills in my pocket here. $10 bills. Going to tell you about my $10 bills. You ready? 50. No. What do I mean? That's terrible communication. What does that 50 mean? Is that $50? If I was you, I'd think, what do you mean, Mr. $50? You got 5 $10 bills? Or do you mean you got like 50 $10 bills? What does that 50 mean? Is that dollars or is that number of bills? Very, very different meaning, huh? That's the issue here. Whenever we're dealing with a number or letter, we got to be clear, is that amount of objects or is that monetary worth, dollars? You know, which one is it? That difference is crucial. So, with that in mind, that's how we set up money word problems. So for all money, also called value, word problems, you have one equation that'll have no money in it at all, and the second equation that's all about money. You basically separate out no money and money. So let me write down for you the crucial facts of this problem. There's 95 cones. The soft serve are $2, and the hard pack are 50 cents, and the total bill was $116.50. $116.50. Okay. So here we go. So the first equation is going to have nothing at all to do with money. It's just going to treat them like objects. So I'm going to use S for soft serve and H for hard pack. That's what they're wanting to know. How many soft serve cones, how many hard pack cones were ordered? So S is how many soft serve, it's a terrible S, how many soft serve cones plus however many hard pack cones adds up to be how many cones were ordered? 95 cones. Why am I using the 95 there? Because that's the only number that doesn't have money involved, huh? The other numbers, $2, 50 cents, and $116.50, those are all money numbers, aren't they? They're going to go in the second equation. Does that make sense? The first equation has got no money, no money, no money. Just treating them like objects. How many of these kind of cone, that kind of cone, how many total cones? I don't care what they're worth, just how many. Right? First equation has got no money. Second equation comes in the money. So you put the soft serve, 2 times S, they're worth $2 each, plus the hard pack, plus 0.50 H, and the total monetary value, $116.50. There we go. See how this one has money, money, money. It's all about monetary worth, right? Because, however, S is going to be, what is S? S is the number of soft serve cones, right? And H is the number of hard pack cones. So the number of soft serve cones plus the number of hard pack cones is 95 cones, and the number of soft serve cones times $2 each gives you the monetary cost of all those, right? And the number of hard pack cones times 50 cents each gives you their monetary total cost. Add that up, total cost, total bill, $116.50. There we go. There's our two equations, 2 letters. So how do you solve 2 equations, 2 letters? Yeah, and to make it simple, how about the rest of the way? This whole section and the next, well, this whole section, what you do money and mixture, I'm just going to always make the fronts be opposites. You can do other things, that'd be fine. I'm just going to make that a minus 2s, add it to the plus 2s, bye s, and solve it that way. I'm just going to do it that way every time. I'll just make the fronts become opposite. So here we go, minus 2, minus 2, minus 2. So what do we got? Minus 2s, minus 2h, minus 190. The bottom is 2s plus 0.50h is 116. $50. Add them up. Does that make sense what I'm doing? I'm making the fronts cancel, aren't I? I'm making the fronts become opposites. That's what I'm going to do every time in this section to solve two equations with two letters. They're all going to become two equations with two letters, the money and the mixture. And so I'm just going to get the fronts to cancel out, make them opposites. They cancel out. And I've got minus 2h plus 0.50h, right? 50 cents take away $2? 150. Minus 150, huh? Equals, and then 116.50 minus 190, what is that, 73.50? Negative, I think. Bring it up here. We good? Two there. Then how do we solve for h? Yep, divide by negative 1.50. So h, so what is that? 49? I remember it. All right, 49. 49 hard pack cones. If that came out, didn't come out nice, clean, whole number, we messed up somewhere. So 49 hard pack cones. It's got to be a clean, whole number. You can't have part of a cone, right? So 49 hard pack cones. Now we got to also figure out how many soft serve. How do we do that? Remember, how many cones are there total? Right? 95 cones total. On all the problems in this section, money and mixture, they're going to give you the total. So it's nice. If you know there's 95 cones total and 49 of them are hard packed, what do you do to find out how many soft serve? You subtract, right, from the total. Does that make sense? So just take 95 now minus the 49. And that'll be something else, I don't know, 46. Soft. 46 soft serve. And we're done. So you could plug in. Remember, isn't that how we normally find the second letter? We plug in. But even easier, you could just subtract from the total. That'll work in this whole section because you've always got the total in the money problems and the mixture problems. There we go. Does that make sense? So money problems, we have two. This is the format you're always going to use for these money problems. First equation has no money, no money, no money. Second equation is money, money, money. And then just make the fronts become opposites. Cancel them out. Get the first letter, then subtract from the total. Get the second letter. All right, I'll move on if you're okay. Unless you have questions. Okay, 762 tickets. Activity cardholder people cost $1.25. The non-activity cardholder tickets cost more. If you don't have an activity card, you pay more. $2.25. Total amount of money is $13.52.50. How many activity card holders and non attended the ball game, the basketball game, right? So a bunch of people came to the basketball game. Some have activity cards, some don't. 762 tickets were sold. Total money collected, $13.52.50. How many of each type? So give it a try. Do the same thing we did on the ice cream problem. All right, we good? I'll dive in and help out a little bit here. So first, the money thing, what we always do on a money problem, first equation is no money. No money at all. So it's just activity card holders, and let's use A and N. You can use X and Y if you want to, but it's easier to use meaningful letters. That way it's, you know what's what. Activity card holders plus non-activity card holders is 762. That's the only number that's not a money number, huh? And then the second equation is all about money. So bring the money in. So $25A plus $225 in is $1352.50. It's all about money there. Is that good? See how it's no money, no money, no money, 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 money. All right, so how do we get those? I'm going to make those front two become opposites. Going to do this every time. So I'm going to multiply the top equation by negative 1.25. Negative 1.25, negative 1.25, all the way across the top equation. What's this other one? Is minus 900 something? Anybody got it? What is it? 952.5? Thank you. 952.5. Good. And then that second equation, I'll just bring that down. No changes. And then add them up. The A's cancel. So that 1N, it's nice. Is it 400? Oh, that's really nice. So N's just 400. That's kind of like done, huh? For N, anyway. We got N. And 1N is just N. So we have N. We have the number of non-activity. There are 400 non-activity card holders. Is that good so far? Now, how do we find how many activity card holders? What's the total? Yeah, this is the total. So just take 762 minus 400. Yeah, 362 must be the A, the activity card holders. Must be 362 activity card holders, 400 non. And we're done. Is that good? Questions on that? Is easy? Pretty straight ahead? Money problems? So again, the first equation is no money, no money, no money. Second one's money, money, money. Make the fronts opposites, cancel them out. Subtract from the total at the end to get the other number. Very predictable, very same thing every time. Okay, 1 can juice, 1 can juice drink is 20% OJ, orange juice. Another is 5% orange juice. How many liters of each should be mixed together in order to get 15 liters? That is 13% orange juice. All right, mixture problems. You done these before? Guys going to take chemistry in a year maybe? You got to finish 103 first. Prerequisites. The next math course, then chemistry. It's usually the prereq. All right, chemistry, lots of fun, mixing things. So I'm going to do the pretty much standard way everybody does these. And do 3 beakers. Like that. 3 beakers. So, and then the way it works is you put the percentages in the bottoms and the amounts in the tops. Percentages in the bottom, amounts in the tops. So 20%, 5%, right? 20%, 5%, 13%. So that makes sense what we're doing first off. So I'm mixing one kind of fruit juice that has 20% orange juice with another kind of fruit juice that is less, it's weaker in orange juice anyway, it's only 5% orange juice, to produce a mix that only has 13% orange juice in it, or that has between them. Notice that the mix percentage always has to be between the other two. Does that seem reasonable to you? That chemistry seem reasonable? Right? Something stronger and something weaker makes something in between, huh? Right? These two add up, mix together to pour into equal the last one. This is the mix one. Right? This is the first one. This is the second one. This is the mix one at the end, right? We're mixing the first two together to produce the final one. Right? This is the mix one. So it makes sense that this percentage would be between the other two, doesn't it? Because something stronger, something weaker, the final product's always got to be between them. Okay, so now in the tops go the amounts, like how much of these? Well, they only gave me one other number in the problem. It's right here. So where do you think that goes? What does it say? 15 liters, that is 13%. So that has to go up here, doesn't it? It's telling us it goes with the 13%. It's saying 15 liters of the 13%. All right, well, I got a couple blanks. I got a blank here, I got a blank there. What do you think goes in those blanks? X and Y, there they are. Our friends, X and Y. Yep, all right, so there's the picture. Now we have 2 letters. Since we have 2 letters means you need 2 equations. If you have 1 letter, you need 1 equation. 2 letters, you need 2 equations. So I've got 2 letters. I've got to get that picture to give to me 2 true equations. How do you do it? Well, the first equation from a mixture problem comes right off the tops. Just x plus y equals 15. X plus y, 15. Just top, top, top. Is that good so far? The second equation is going to come from multiplying. So 20 times x. By the way, you don't even have to make that a decimal. I'll explain why later. For now, just leave it. You don't need to make a 0.20 or 0.05. Just make it a regular 20, a regular 5, and then a regular 13 times 15, which is some number 150 and 45, 195? Right, that right?
Yes.
Thank you. All right, so everybody see what I did there? There's my 2 equations. The first equation comes from just top, 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 just right across the top. Second equation comes from multiply. See what I mean by multiply? I multiplied 20 times x, and 5 times y, and 13 times 15. And that actually made a different number, huh? Good? There's how you get your 2 equations. From mixture. What you're basically doing, if you want to know real life what's happening, you're just adding up the amount of fluid in the top equation, right? However much amount. See, the tops are the amounts, the bottoms are the percentages. So the amount of fluid, whatever it is, coming out of bucket 1 plus the amount of stuff coming out of bucket 2 has to be the total 15, right? That's just adding up amounts. Now, what's the multiply thing? Well, that's getting you the actual OJ, the actual orange juice, right? Because if the first bucket is 20% orange juice, then 0.20, and I'll explain the decimal thing in a minute, 0.20 times X gives you the actual orange juice amount, right? Because it's 20% of that, 20% times that is the actual amount of orange juice coming out of the first bucket. Just orange juice. There's other stuff too, but just orange juice. And then 5% times Y gives you the amount of orange juice out of the second bucket, and 13% times 15 is the amount of orange juice total in the final thing. So the orange juice plus orange juice must be orange juice. That's why that's true. So there's our two equations. Now, why do I say you can skip the decimals? Well, don't write this, but if you put them in there, 0.20, 0.05, this would be what, 0.13, I can just multiply through by 100. It's an equation, left side, right side, 100, 100, 100. Move all the decimals, 2, 2, 2. It'd go 2, 2, 2, right back where it was. So might as well just skip the whole thing. So that makes sense. Whenever you have decimals on both sides, you can skip them because you can multiply through by 100 and get rid of them, right? All right, so I just skipped the whole thing to make it easier. All right, there we go. So now we solve it. Let me bring it up here. So we have x plus y is 15, 20x plus 5y is 195. Now, how do we solve that equation? Same way. What are you going to do? Make the fronts opposites, right? So what am I going to multiply the top equation by? Negative 20. You can do negative 5. I'm always doing the fronts. But you could do something different if you wanted. I'm just going to always do the fronts. I found that makes it easier for students to just have one plan. But you're right, negative 5 would work fine. So I'm going to multiply through by negative 20. That good? So I'm just making the fronts opposites. I'm just going to always do it that way. So that'll always work. Minus 20x, minus 20y. Is that minus 300? And the bottom one is just 20x plus 5y is 195. Add them up. X's cancel. Minus 15y minus 105. Is that right? Yeah. Last step to get x alone. Is that 7? Yeah, 7, huh? Y is 7. So y is 7. How do we get x? The total again, right? Like I said, all these you're going to have the total. The total is 15. 15 is the total. So just go, oh, okay, I'll do the same thing I did in the other ones. Just come over here. Just take 15 minus the 7. 8, that must be x. Because they're always going to be giving you the total on these money and mixture problems in this section. So x is 8, y is 7, we're done. Now what about the fact that in the actual question, coming up here, they're going to say, how many liters of the 20%? Is that x or is that y? I mean, I have the answers, I'm just not sure which is which. They're saying how many liters of the 20% should be in the mixture? Yeah, based on my picture, I put x with 20, so it would be 8. 8 is the amount of 8 liters of the 20% stuff should be mixed with 7 liters of the whatever 5% stuff to produce what we want. We just did a mixture problem. Chemistry has come. Is that good? It's like chemistry wants you to take these math classes first, so when you get there, you're ready to go for this kind of stuff. No questions? All is well? All right. Okay, so try this one. Parking meter contains nickels and dimes. Nickels and dimes worth $6.05. 78 coins in all. Find out how many nickels are. So that's what's in the parking meter. It's a bunch of nickels and dimes, only nickels and dimes, worth $6.05, 78 coins in all. How many of each? That's a money problem. Clearly, it's literally money. So it's a money problem. Solve that money problem. So two equations. First one, remember how the money ones work, right? First one is no money. Second one is all about money. That's how we do money problems. You get the hang of the different two styles, right? So money problems are no money, no money, no money, and money, money, money. So nickels plus dimes is, should I do 605? Not yet. 78, because that's the non-money number. Remember first equation, no money, no money, no money. That's just objects. Nickels and dimes total 78. Who cares what they're worth? Nothing about monetary value in the first equation, just objects. No money, no money, no money. Second, you bring in the money. What's a nickel worth? 0.05, right? 0.05 in plus 0.10D is 605. Does that make sense there? On the second one, money, money, money. All right, you can take it from there, right? Can you make the fronts opposites? Minus 0.05, minus 0.05, minus 0.05. Right across the top to make the fronts become opposites. Come on up here. Minus 0.05 in. Minus 0.05D. Is I don't know. What's 0.05 times 78? What is it? Negative 39? 3.9. Yeah, thank you. Second one, 0.05 N plus 0.10 D equals 6.05. Add them up, cancels out. Is that good? Subtract these, 0.05 D. Subtract these for 215. Divide by 0.05. So 23? 43. 43 dimes. How are we doing? You guys getting that? Am I racing ahead of you? Is that okay? See how we do that? It's just another money problem, right? It's our third one. It's the same old thing. First equation is, you know, no money, no money, no money. Second equation, money, money, money. Get the fronts to be opposites. Cancel them out. Now, dimes, how do you get nickels? They give you the total, 78, right? They're always giving you the total on all these. So just subtract 78 take away the 43. What does that leave? 35 nickels. Must be 35 nickels left. And we're done. Questions? No questions? All is happy? After this, because we pretty much got these down, they're just going to repeat after this. So Brazilian coffee. So we get the Brazilian. Brazilian is $12, and the Turkish is 16 per kilogram. You're going to mix them together. You want to create a mix that sells for 14 per kilogram. You want 204 kilograms. You want 204 kilograms in the mix. Now, how do you know, this is a little tricky, as you read this question, how do you know if it's a mixture problem or if it's a money problem? Because it's kind of got both, doesn't it? It's got money, it's talking about mix. Well, bottom line, if they talk about mixture, it's a mixture, even if it has money. Well, this is mixture. If they say the word mix, which they have said a couple times, if they say the word mix, it's a mixture problem, even if it's money. It's not a money problem, it's a mixture problem. That trumps it. So it's a mixture. This is a mixture problem. So treat this one as a mixture, which means it's beaker time, or buckets, or whatever you want to call them. All right, I'm going to make that a little smaller. Got to bring out the 3 buckets. Percentages in the bottom. Amounts in the top, right? So take it from there. See what you remember about mixture. We've only done one of them. Oh yeah, we don't have percentages on this one. So who's going to play the role of the percentages? That's the money. Because yeah, percentage is like strength level, right? It was orange juice strength level. This time it's monetary worth, right? How strong the Brazilian coffee is, the Turkish coffee, and the mixture. That's like the percent. So put the money at the bottom and the amounts at the top. So, $12, $16, and $14, right? See how the final coffee price is between the other two? It's always got to be that way, right? You got the cheap stuff, 12 bucks. The expensive stuff, $16 a kilogram. The final product's going to be a mix of the more expensive and the cheap. Can be between them at $14 a kilogram. All right, now what? They're giving me one other number. It's the 204. Where does it go? Top right, because it's 204 of the mix. So what goes above the 12 and the 16? X and Y, or you could do B for Brazilian. I think it might be easier. And T for Turkish. But you could just do X and Y. That's okay too. But it's nice to use meaningful letters. That's easier to know what's what at the end. So there we go. Take it from there. 2 letters. You got to get two equations out of that thing, right? All right, so two letters, we need two equations. How do you get your two equations? The first equation comes from the tops, right? B plus T is 204. Second equation comes from multiplying. Top times bottom. B times 12, 12B. 16T. And 14 times 204. So what is that? 2856. Thank you. Okay, so there's our two. Everybody good with that? See how you get the two equations out of a mixture? Top, 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 and multiply, multiply, multiply. All right, you know the drill. Make the fronts opposites. Make the fronts opposites. Get them to cancel. So I'm going to multiply through by negative 12, negative 12, negative 12. What are we going to get? Negative 12b minus 12t. 12 times 204. What's 12 times 204? Yeah, negative 12. 24, isn't it 24 something? One more time, what are you getting?
Negative 2448.
2448? Yeah, that looks about right to me. 2448 there. And then the second equation, 12b plus 16t is 2856. Add them up, the b's cancel. Get 4t there. Clean that up a little bit. Get 4t equals, I don't know what, 408. So bring it up here. So I've got 4t equals 408 divided by 4. T equals 102. 102 pounds of the Turkish coffee. Kilograms, I guess it is. And then how do you find the other one? Subtract from the total, right? Total's 204. So 204 minus 102. It's just going to be 102 also for the Brazilian coffee. It's an equal amount of each kind of coffee. Why is that? Because the final product's right smack in the middle. See how that is? The final one's right in the middle. Right? We want to mix some more expensive $16 coffee with some cheap stuff, $12 coffee. We want the final product to be right in the middle, so use the same amount of Brazilian and Turkish. If you wanted the price to come out closer to the Turkish, like $15, then you'd use more Turkish, right? Or closer to the Brazilian, like $13 per pound in the end, you'd use more Brazilian. Since we want it right in the middle, we use equal amounts. We could have guessed that from the beginning. It's got to be equal amounts. Is that okay? You guys feeling good about mixture? You okay with mixture? You okay with money? Those two different kinds? Questions on that one? So again, mixture, when it says mix, it's a mixture problem, even if it has money in it. The money or the percentage goes in the bottom, one number on the top, the X and the Y or the B and the T there, and then top, 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 and multiply, multiply, multiply for your second equation. Get the fronts to be opposites, and the rest is the same. A lot of ground today. Okay, this will be our last mixture problem. So how much of the 10 SPF Kinney's suntan lotion and the 25 SPF Coppertone suntan lotion should be blended to make 50 fluid ounces of sunblock that is rated 20 SPF? So it's a mixture. How do we know? They're using the word blended. Same thing, right? Blended, mix, same thing. So go ahead and set up the beakers on this one, the buckets. See if you can get stuff to happen. It's good. All right, so 3 buckets. Remember the percent. Now, we don't have percentages again, and the amounts go on the top. We don't have percentages. What's playing the role of the percentages this time? SPF, right? It's the strength level, whether that's the price of coffee or the percentage of orange juice or the SPF of suntan lotion. SPF stands for, somebody just told me in the last class, sun. That was it. Roberto's here. He's here to help us. There's our assigned tutor. If you have any questions, he's the man. This last week when things get hard. Yeah, sun protection factor. Yeah. Okay. So the 10 and the 25 and the 20. Notice again, the final product, the mix, is between the other two, right? You're mixing something stronger with something weaker. The final thing's got to come out between them, doesn't it? And then they're giving you one other number, the 50 fluid ounces of the final mix. So the 50 goes there. The other 2 spots are X and Y. I think I'm going to put K for Kinney's, C for Coppertone, but X and Y is fine. You know, whatever. Take it from there. So you know how to get your 2 equations, right? So the first equation is from the tops only. K plus C is 50. Number 2 is multiply. 10 times K plus 25 times C is 20 times 50. What is that, 1,000? Like that. All right, good. There's our 2 equations. Top, top, top. Multiply, multiply, multiply. That's what we always do for the mixture. All right, you know the drill. Make the fronts opposites one more time. This will be the last time today. Then we'll go on to some different kind of question. We've had enough of these. We've had a lot of these. So multiply the top by negative 10. So negative 10K minus 10C minus 500. The bottom equation, 10K plus 25C is 1,000. Add them up. K's cancel. What do we get? 15C is 500. Oh, we're going to get an ugly answer, huh? Divided by 15. What does the calculator tell you?
33.333.
Oh, yeah. 33 point. And remember what we talked about? What's 0.33333? Because they want a mixed number. If you look back over here, they want a mixed number. So that's 33 and a third. Right? Well, first, actually, before we do that, let's get the other answer. How do we get the, that's the C. before we convert them or anything like that. You know, so that's the C, the amount of copper tone. So how do you get the other one? Subtract from the total, right? The total is 50, right here, 50, minus 33.3, what's that? 16.7, does it come out 16.7? That must be the amount of whatever is Kenny's that needs to be in the mix. Now, reality, if it's not 16.7, it's actually 6's forever. The problem is I only put 1 3. But you should know it's really 6's forever because it's really came from 3's forever subtracted. How are we doing? This making sense? Right, so I did the work. I got the copper tone thing to be 33.333. Then subtract from the total. 50 minus 30, right, because 50 is the total. 16, it's 16.7, but really it's 6's forever. If I'd used 3's forever, you'd get 6's forever here. So, okay, but they want a mixed number, so let's make these mixed numbers. This one is 33 1/3, because that's what 0.3's forever is 1/3. And if 0.3's forever is 1/3, what is 0.6's forever? It's twice as big, right? 0.3's forever, 0.6's forever, that's twice as big. So this is going to be 16 2/3 for Kenny's. Is that good? Does everybody see that? Am I making any sense there? So again, when I point, you want to just have cold memorized. 33 cents is 1/3 of a dollar, huh? How about that? It's almost 1/3. 3's forever would be exactly 1/3 of a dollar, right? You guys know that 33 cents is almost 1/3 of a dollar. So 0.33, that's 1/3, right? I mean, if the 3's go forever, it's 1/3. So 33 1/3, and then 0.6 is forever. That's twice as big as 3's forever. So that's 2/3. All right. Question.